And example 4 is really challenging just for our minds to picture. So what I'm going to try to do is I'm going to try to draw the situation and hopefully you can picture it. What's hard for this question is that it deals with 3 dimensions, but when we're trying to draw things on a paper, we have 2 dimensions. Okay? So we'll break it up a little bit. What it says here, a communication tower is 35 meters tall. David is due north of the tower and measures the angle of elevation of the top of the tower as 70 degrees. So I'm going to just draw a tower, and I'm going to draw David right here, and he measures his angle of elevation of 70 degrees. This will make a right angle triangle because we're going to assume the tower is straight up and down unless it says otherwise. Okay? So this is David's little picture. And then we have the same tower, and Brenda is standing a certain distance away. Does it say anything else? We know the tower is 35 meters tall. We know this tower is still 35 meters tall. Brenda measures her angle of elevation as 50 degrees. Okay? And now the problem is like, oh my goodness, how far apart are Brenda and David? I've got them on different triangles. So what I'm going to do is I am now going to use the bearings. And imagine I'm looking from the top down. So now I got in, I was doing this problem. First of all, I started on the problem. I'm walking around, and I drew these diagrams while I'm walking around on the ground. I went right here. I saw David. I saw the tower. He measured 70 degrees. I drew that triangle. I went over to Brenda, saw the triangle when she was measuring. Now I got in an airplane, and north, south, east, and west, and the tower is now just a dot because I'm looking straight down on the tower. Does it make sense that David, which I'm going to represent by the green dot, is due north? That's where David is. Right? I gave him a green hat so when I was in my airplane I could see him. And I gave Brenda a blue hat so I could see where Brenda is from the airplane. And she's at a bearing of 175 degrees. So 175 degrees means you go from north and measure, right? This angle here would be 175 degrees. And there's Brenda. And I'm also going to draw, I guess on Brenda's, I'm going to draw, whoa, that's not what I wanted, not that color. Brenda's got the blue hat on. I'm going to draw the line in blue to Brenda. Would you agree that that would be that length? And the line in green for David, that would be this length. And I could connect now the dot between David and Brenda and make an X. So from the top, I can see their green hat and their blue hat and try to figure out how far away they are. Now, I'm going to attempt to draw all of this in a 3-dimensional picture. So I'm imagining this situation from the top above. I'm going to pick that up, and I am going to say, here's my tower. Okay? Straight north of that tower is the green line. Whoa, that's not green. Man, struggling with colors today. Straight north of that tower, and I'm doing it on an angle because this is 3-dimensional. Here's David. This is a 90 degree, even though it doesn't look like a 90 degree anymore because we're dealing in 3 dimensions. And he measured the top of the tower here at 70 degrees. At a bearing of 175 degrees, so from the tower over, that's not blue. 175-degree difference in between them. Here's Brenda. She measured to the top of her tower. This is a 90-degree angle in there. That's kind of weird. Doesn't look like 90 degrees at all, but that's what three-dimensional pictures do. And she measured this angle to be 50 degrees. And now we want to find the distance in between them. Three-dimensional drawing is hard. Depending on, we could maybe I could take this and turn it even more. Would that be nicer if I put the tower here and put Brenda here, David there? This is the green line. This is the line between them. This is the blue line. Tower is always in black. And we've got angle of elevation up to this one at 50 degrees. Angle of elevation on this one at 70 degrees. These are 90-degree angles, even though they don't look like it, but we're dealing in 3 dimensions. Trying to turn this picture so that we can see it as best as possible. Yes? Why are they 90? Because they're on the ground and the tower is straight up. So the ground and the tower we're going to assume is 90 degrees, because this isn't the Leaning Tower of Pisa. In a question, anytime they say a building, you're going to assume that that building is going straight up unless otherwise stated in the question. All right. With our wall, in the last question, that wall normally would have been 90 degrees, but they told us it was bent. It was leaning at 70 degrees. Okay. Oh. All of this just to visualize. Question?
With all the other questions, we're going counterclockwise with the angle, but you went clockwise.
Yeah, for a bearing, and we had this in our notes the other day, bearings start at north. Anytime you have an angle in standard position, it starts on your positive x-axis, but bearings start at north and go clockwise. Okay. So, I think these top 2 pictures are very nice because they're 2-dimensional pictures where we have a 90-degree in here. What's nice about 90-degree angle triangles? You're allowed to use SOHCAHTOA. We want to find, in the end, we want to find this distance between Brenda and David. That distance made a triangle. This angle here was 175 degrees. But if I pull that triangle out all by itself, sometimes this is helpful. I want to find this length between Brenda and David. This had a blue line and a green line, and we knew that this angle was 175 degrees. The problem with the triangle that we want to solve x on is we don't have 3 pieces of information. You need 3 pieces of information, including at least one side, in order to be able to solve this. And we have just an angle. So currently, looking at this, we can't solve it. But if we look at our other triangles, those top 2, can you see that you can use SOHCAHTOA? With SOHCAHTOA, you just basically need 2 pieces of it. Well, you still need 3 pieces of information, because technically, your 3rd piece of information is the 90 degree. We can solve those triangles. In fact, for the green one, which I'll do in green, if I want to find, I'm going to call it little d for David, technically, little d should be opposite of big D. What letter should we use? E? E is problematic for me because E is actually a number in math. Euler's number, yeah. There's like, it's on your calculator and everything. There's like 2 special letters that have numbers associated to them. You work with pi all the time. You never knew there was a number E. We do now, so I don't want to use E because it's kind of a number. But F, right? I'm getting frustrated. Let's just use F and G. Sounds terrible. Okay? So let's say that's F, that's G. Maybe I'll make G for later. want to find f, would you use sine, cos, or tan? Tan of 70 degrees, opposite side, which is 35, over f. So f is equal to 35 over 10 of 70. You know how to do that with fractions, right? You can just flip things, switch places. Really nice and handy. So now, I type that into my calculator. 35 divided by 10 of 70. 12.7389. 12.74. In fact, I'm going to store this as f. Why not? Maybe we need to use it later. So that was my 12.4. Same thing on, hey, notice how I solved for the f, which was the green line? I color-coded it in green on purpose, because as soon as I found it there, I'm like, hey, I now know that on this triangle as well. And I'm that much closer to finding 3 pieces of information on this bottom triangle. The blue line, that's G. I can solve that as well. Tan of 50 degrees will equal G, equal 35 over G. So G will equal 35 over tan of 50, which is equal to 29.36. I'm going to store that as the letter G. 29.36, 37. So what if I, in my 3-dimensional picture, can you see that we found this f here to be 12.74, and we found this length here to be 29.37. I did that by looking at the individual right-angled triangles for David and the individual right-angled triangle for Brenda. Now, when I look at the triangle that included x, I now have 3 pieces of information. I cannot use SOHCAHTOA though, because it's not a right-angled triangle. I can use the cosine law. Sine law wouldn't work either because I don't know an angle and its opposite side. I just know an angle. So when setting up my cos law, the x squared would be on this side and the cos of 175 would be on this side. And then you would get 29.37 squared plus 12.74 minus 2 times, oh my goodness, 29.37 and 12.74. And this is where I'm going to be super happy that I stored everything into my calculator. Because I can just go f squared plus g squared minus 2f g cos of 175. Oh. Did you see how I did the wrong bracket? 1770. So x squared 1770, and I can just square root that or put it to the power of 0.5. Same thing as square rooting, and I get 42.1. How much does it want me to round to? That is scary. That's the bell. You guys can go. I'm just kidding. Right? They're doing, you know what, they're just doing a test to see who's brought their cell phone to class.
Yeah, everyone will pull their
And you
cell
guys,
phone.
you guys are safe, it was just mine that went off, right? See, you guys, very good, I'm very impressed. The one thing I know about those Amber Alerts, they go off on people's phones at different times, don't they? So who's is gonna be next?
So there's a chance that someone else's will go off later.
Yeah, we're gonna find out. Anyways, we got x equals rounded 42. Is there units in this question? Meters. This was an expensive question to do. You had to hire a plane, go up in the air, lots of walking. But three-dimensional questions, those are the hardest. So you can circle questions 9 and 12.